Welcome to the deep dive. Today we're going to tackle a really fundamental question left over from the standard model of particle physics.
Yeah, it's a big one. It's about the strong nuclear force quantum chromodynamics, or QCD.
Exactly. And specifically, why does it operate using the very specific, kind of complicated mathematics of the cis-U3 symmetry group?
Right. Why that group? I mean, cis-U3 dictates there are exactly 3 types of color charge: red, green, and blue.
And precisely 8 force carriers, the gluons.
Exactly. And in the standard model, well, we just plug cis-U3 in. It's treated as a fundamental parameter.
Just taken as a given.
Pretty much. So what we want to explore today is whether string theory might offer a deeper reason. Could this cis-U3 structure actually emerge from something else? Maybe from geometry.
Okay, let's unpack that. If string theory is going to explain QCD, what exactly does it need to build?
Well, 2 key things. First, it has to explain the quarks, the matter particles. They carry a single unit of color charge. That's what physicists call the fundamental representation, the math BF3.
The basic building blocks of color.
Right. And second, it needs to give us the gluons, the force carriers. They live in what's called the adjoint representation, the math BF3. And this is crucial because it means gluons interact with each other, which is why the strong force is, well, so strong.
And so complex. Okay, so how does string theory bridge this gap between geometry and these particle properties?
The key players here are D-branes. You can think of a D-brane as like a surface or a membrane existing in higher dimensions.
Okay.
And the crucial rule is that the endpoints of open strings must lie on these D-branes. They're stuck there.
Got it. Strings have to end on these surfaces.
Exactly. Now here's the magic. If you take a stack of non-abelian identical parallel D-branes, the physics living on that stack automatically behaves like a UN gauge theory.
Whoa, okay. So the number of branes directly gives you the type of theory. Null branes means...
Precisely. It's a direct link. The information about the gauge group comes from the string endpoints.
How does that work?
Each string endpoint carries something called a Chan-Paton factor. You can sort of think of these as labels.
Labels.
Yeah, basically index labels. If you have a dollar branes, a string stretching between brain dollar and brain J dollar carries labels. Delta brain. These labels essentially become the indices for the force fields, the gauge bosons. For Nile branes, you get line long times mile possible combinations, forming the basis for the group structure.
Okay, I think I see. So to get our target, QCD, which is based on...
And exactly 3 parallel D branes. Let's call them our color branes.
Right, so 3 color branes should give us $3.
This does. A stack of 3 branes naturally generates a UDR gauge theory on its word volume.
But wait, that dollar. Mathematically, that group has $3 and 3 times 99 generators, right? Which means 9 force carriers. QCD only has 8 gluons. Where does the 9th one go?
That's the subtle but really important part. The UDL group isn't simple. It actually splits. It's SE3 times the UR factor. So URA3 times the U add those 9 initial massless vector bosons generated by the 3 branes. 8 of them correspond to the $63 part. Those are our gluons.
And the 9th one, the extra U dollar.
That single U dollar mode has a very specific physical meaning here. It represents the collective center of a mass motion of the entire stack of 3 branes moving together through the higher dimensions.
Oh, I see. So it's like the whole structure moving, not the internal interactions.
Exactly. It's an overall movement, not an internal force dynamic. And crucially, this overall U dollar mode doesn't interact strongly with the individual color charges. It effectively decouples from the QCD dynamics.
So it's there, but it doesn't play a role in the strong force itself.
Correct. You're left with just the interacting SE3 part, which has precisely the 8 gluons we need. And these gluons correspond to open strings that start and end on that stack of 3 color branes.
That's really elegant. So the force carriers are strings confined to the color brane stack, but what about the quarks, the matter particles that carry the color?
Good question. Quarks fit into this picture beautifully. Remember, quarks are in the fundamental math PF3 representation.
They carry 1 unit of color.
Right. In this geometric setup, quarks arise from open strings that stretch between our stack of 3 color branes and some other set of branes. Let's call them flavor branes.
So they connect different stacks.
Yes. A quark string has one end on the color stack, say on brane number 1, 2, or 3, giving it its color charge, red, green, or blue. The other end is on a flato brane, which determines its flavor, like up or down.
Ah, so the geometry makes the clear distinction. Gluons are internal strings on the color stack. Quarks are strings connecting the color stack to something else.
Exactly. Force versus matter becomes a distinction in string configuration.
So let's wrap this up. What does this perspective really mean for you listening? It suggests that color charge, this seemingly abstract property, might not be fundamental itself.
Right. It could actually be, well, almost like an address label. It tells you which specific geometric object, which of the three colored d-branes a string endpoint is attached to within a higher dimensional space.
Geometry dictates the fundamental forces.
And this isn't just a neat explanation. This geometric picture is incredibly powerful. It's one of the foundations for something called the gauge-gravity duality, or holography.
You mean like holographic QCD?
Precisely. That duality allows us to take really hard, strongly coupled problems in QCD, things like why quarks are confined inside protons and neutrons, which is notoriously difficult to calculate.
Yeah, practically impossible sometimes.
And map them onto potentially much simpler problems involving classical gravity, just in a different, curved, higher dimensional space-time that's related to this brane setup. It gives us a whole new computational toolkit.
So understanding the geometry helps us calculate things we couldn't calculate before. That's huge. Okay, something for you to think about before next time.
If the number of colors, 3 in our universe, is literally set by the number of color branes.
Does that mean you could imagine a universe with, say, 4 color branes? Would that give you an $6 strong force? What would that universe look like?
Something to definitely chew on.